Alright, in 5.1 and 5.2, everything we did revolved around standard form. Do you remember what standard form was of quadratics? Y equals
x squared
a x squared plus bx plus c. Alright, so today we're still dealing with quadratics, but we're just going to look at them in a different form. Standard form, there's no parentheses, we've got a, b, and c. Okay, vertex form is this, and we do have parentheses. We still have the same a, but instead of b and c, now we have h and k. Do you remember h and k from when we did absolute value equations? Okay, h moves it right and left, k moves it up and down. It's same sort of thing. All right, so we said h is what kind of movement? Horizontal or vertical? It's an h, so what goes with it? Horizontal. My O's are crazy today. All right, and we said in the equation, let me write that out because that makes a difference. In the equation, if h is positive, so right here if it said plus 4, would we go 4 to the right or 4 to the left? Do you remember? H
You go to the left.
is weird and backwards. Yes, so you go to the left. So if h is positive in the equation, the graph moves left. If h is negative in the equation, the graph moves right. And we're talking about from the vertex of the parent function, which is 0, 0. So it would move, like say it was that 4, it would move 4 to the left from the origin. All right, now k is vertical. If k is positive, which way does the graph go?
Up.
If k is negative, it goes down. Okay, so h is the weird, we hate you because you're so confusing, 1. H is always in the parentheses with x. And k is always hanging out at the end. Okay, h always sticks with x. Now, outside of the equation, h and k give us our vertex. So our vertex is hk. That's why this is called vertex form, because it just gives it to us. But h is weird, and h is opposite of what it looks like in the equation. Nee. Let me give you an example. Say we have y equals 2x plus 4 squared minus 1. Okay, look at our formula here. It says minus h, right? So how did we get from minus h to positive h? Whoops, don't do that. Huh? It's how they got to us, but what would make that negative turn to a positive? What about another negative? So can we write this out as 2x minus negative 4 squared minus 1? I need another parenthesis. So in reality, though it looks positive right here, the h is this negative 4. Okay, so this is h, and this one is k. So our vertex here would be negative 4, negative 1. Okay, so always just take the opposite of what it looks like. If it would have said x minus 4 right here, our vertex would have been a positive 4. I know, it is so weird and annoying and poop on it because it's just great. It's annoying. Okay, but that's how it is. Okay, so you'll always take the k. K, it's awesome, it's simple, it's what it is, but your h will always just take the opposite sign of what you see. Okay, or if you're going backwards, if you have the vertex and you're putting it in there, when it's in there, it's going to have the opposite sign. All right, and what we learned on Friday is that the x coordinate from the vertex is also your axis of symmetry. So x equals h is your axis of symmetry. All right, so what are we doing with all this today? Well, we're going to do 3 different types of problems. The first one, they're going to give us an equation and we are going to graph from it. All right, kind of similar to what we did on Friday, but we're starting in vertex form. It takes less work, promise. Okay, the next example that we're going to do is they're going to give us a graph, and from it we are going to write the equation in vertex form. All right, so these two are kind of opposite of each other, what we start with and what we end with. The last one, it's no graph. It's just starting in standard form, so that's the ax squared plus bx plus c, and we're going to end in vertex form, which is what we're learning today, is vertex form. All right? The step-by-step instructions for all 3 of these are right here. You just figure out what you're starting with and what you're supposed to end with, and follow whatever steps from there. All the examples are on the back, so let's go to the back and do them. All right. Our equation is right here in vertex form, all right? If vertex form, let's write it down just so we don't forget it. Y equals a times x minus h squared plus k. All right, so step 1 is to find our vertex. And our vertex is HK. So this right here gives us H. It's a plus 1 in the equation, so what is H as our vertex? -1. It's the weird, don't understand it, but it's weird. Okay, and then K is whatever's hanging off the end, so what is our vertex? -1, -4. So you can go ahead and plot that. Next step is our axis of symmetry. We said that the axis of symmetry is x equals h. So for us it's x equals -1, right? So you can graph that as well. It's just a dotted line through the vertex. Okay, so according to the front, step 3 was to graph those things. So step 4 is to get another point. So we need another point. To do that, we can just find an x, plug it into our equation. I didn't really leave myself enough room to write it out. And then we'll get our y. So what x do you want to plug in? 1, okay. So let's do that. So we're going to plug in 1. So it'll be 2 times 1 plus 1 squared minus 4. Well, 1 plus 1 is 2, right? So now we have 2 times 2 squared minus 4. 2 squared is 4, so 2 times 4 minus 4, which is 8 minus 4, which equals 4. So we have the point 1, 4, which is actually a little off our graph, but that is okay. Once you graph that one, you can reflect it across. And then make your parabola. Remember that it is not a V, it's a U. It might be a skinny U, but it's still a U. Was that too bad?
Can you move down a little bit? There.
The tricky part is taking the H and just changing its sign. All right. So if we were looking at that, we would have said it moved left 1 and down 4. So from the origin, we went left 1 and down 4. And there's our new vertex. All right. Any questions about that one?
What about step 3?
Step 3 was graphing the vertex and the axis of symmetry. Yeah, so we did that. You can write it out if you want to. It's written out on the front graph. Okay. Let's go to the next one. So this one, we're starting with a graph, and we are supposed to write the equation in vertex form. All right. So
We know it's going to be x plus 1.
yes, let's go ahead. Let me write out our skeleton that we need to fill in, our vertex form equation, and then we'll go from there. That's a K at the end. Okay, so what is our vertex point from the graph? -1, 0. So that -1 is H, right? And the 0 is K. So if we plug those in, this is step 2 to plug them in, we'll have y equals a x minus our -1 squared plus 0 for our k. All I did was take the h and put it right there, and the k and put it right there.
You have to write it as a double negative?
No, because we're going to simplify it. So the next step is to simplify it. So that gives us y equals a, the double negative makes positive, and then the 0, we really don't have to write that. So now we just have y equals a times x plus 1 squared. So the last thing we need to do is find out what a is. And kind of similar to what we did before is we are going to use the other point that they give us, which is -2, 2, and plug it in. So that'll be, instead of y, I have a 2 to plug in. So it'll be 2 equals, still don't know a, but instead of x, I've got -2 plus 1 squared. And then we just solve this for a. So Clark, what's -2 plus 1? That is a -1. Okay. All right, so what's -1 squared? It is 1. Okay. Come up here. So that's 2 equals a times 1, which is just a, right? So 2 equals a. We figured out what a was. So step 4 is to sub in a. So we're going to take this equation with a together, which is a, or y equals 2 times x plus 1 squared. And that is your answer. So many arrows. So always start with your vertex. Plug that in. And then use another point on the graph to figure out what A is, and then go back to the equation. All right, so we had to figure out H, K, and A. H and K were pretty obvious. A took a little work. Any questions there? No? All right. Last question involves no graph. We're not starting with a graph. We're not ending with a graph. We're starting with standard form, and we're going to convert it to vertex form. All right, so step one is to figure out what our H is. Okay, so H, we said is the same as our axis of symmetry. What formula did you use on your homework for axis of symmetry?
B over negative 2a.
Negative b over 2a. Very good. So what is b for this one?
12x, or 12.
Just take the number, yeah. 12 divided by 2 times what's a?
3, negative 3x squared.
Yeah, and just take the number. So it's like negative 3 and 12. Those are the numbers you take. All right, simplify that. It's negative 12 over negative 6, which is positive 2. So H equals 2. So circle that if you feel like you're going to lose it. Okay, so we got our X of our vertex. That's H. All right, now we got to get K, which is the Y of the vertex. Now, similar to what you did on your homework, is that you plug that 2 back into the original equation. So K will equal negative 3 times, instead of X, write 2 squared plus 12 times 2 plus 5. So we just took this 2 and put it right here and right here.
4 is negative 12 plus 24 plus 5.
All right, so simplified 2 squared to 4. And then 12 times 2 is 24 plus 5. So that's negative 12 plus 29. What is that? 17, I think. All right, we're doing good. We have H and we have K. Any questions about what we've done so far? Okay, we had to incorporate our standard form equation for the axis of symmetry, which is negative b over 2a. All right, so make that connection in your head. The H is the X, that's the axis of symmetry. Okay, so we can use negative b over 2a. All right, so now let's just kind of, in step 3, summarize what we have. We have that the vertex is what point? Vertex is HK, so what's our vertex? 217. This is H, this is K. We also have our A that we need in our vertex form. What did we say A was?
Negative 3.
Negative 3. It's the same A. It's the exact same A. So the next step is to put it all together. So this kind of step 4 and 5 together. But we're going to take y equals a x minus h squared plus k. That's our vertex form skeleton. And fill in a, h, and k. So what will our final formula be?
Mod equals negative 3.
Mm-hmm. It's going to be
X minus 2.
x minus 2
Plus 17.
plus 17. It's going to be minus 2, because this is positive, so when you plug it in with the minus, it's a negative. Okay, so it's in the formula, it's opposite of what it in reality actually is. But that is your answer. Right there. That's standard form. Any questions? Or that's vertex form. Any questions at all? No?